Ladies and gentlemen, here in Santa Clara, California, here we are. Yet another keynote. This is day 2, general session. We've got Abiquo coming up next. We've got all sorts of things coming up afterwards. So let's give it up for the CEO of Abiquo, Pete Malcolm. And he is going to take us again on this enterprise theme onto next generation cloud management. Pete Malcolm.
Thank you. Morning. I thought I'd start out by showing you a little video which gives you an idea of what Abiquo does, what we're about, and also introduces some of the issues that we're facing today. So here we go.
Virtualization. Great, isn't it? We can move things around if the hardware fails or needs upgrading, or if we need more power, and we can move workloads around to more efficiently use the hardware we already have. And stop us buying more hardware we don't really need. Yep, it's pretty awesome. Yeah, except for all the ways that it isn't. See, all this moving around does make it kind of hard to track where everything is. And working out just where to put everything to get the best utilization is actually pretty difficult, especially if you have to do it over and over every day. And what about governance, security, and compliance issues? Even so-called easy deployment is still a big headache for the overstretched infrastructure team. And of course, these problems aren't getting any smaller. But hey, why worry? Cloud computing is going to fix all this, right? What if the cloud could solve the problems of virtualization? If you could fully empower your users to manage their own environments without any risk to your infrastructure, freeing your IT team to focus on delivering the most cost-effective resources at the required service levels, and have it all automatically operate according to your organization's business policies. What if you could make virtualization and the cloud work the way you need them to? Well, they can. At Abiquo, we've created a solution that fixes all the old virtualization issues and delivers the cloud just the way you need it. Abiquo provides each organizational group with total control of its own virtual enterprise, where they can configure and deploy resources any way they want to, in seconds, and without any risk to the infrastructure or anyone else's virtual enterprise. Abiquo supports all 6 major hypervisors and ends vendor lock-in by providing drag-and-drop conversion of virtual machines between any of them. It lets your IT team manage infrastructure across the globe, whether it's equipment you own or services you buy in to provide elasticity, all through a single pane of glass. Abiquo lets you control resource consumption while providing drill-down accounting for billing and chargeback. Real-time displays and statistics keep you informed and make capacity planning and efficient demand-based elasticity a reality. And Abiquo's highly sophisticated business policy ensures governance, security, and compliance requirements, as well as your business goals, are consistently and automatically enforced every time. Come experience the industry's most sophisticated enterprise cloud management solution today. Abiquo.com.
Okay, so that explains a little of what we're about. I'm going to focus on one particular aspect of what we showed you there today, but we believe that there are really 3 key pieces or 3 key stakeholders in the cloud management area. They are obviously the infrastructure side, and of course we're all, all the discussions around cloud are how we can reduce cost on the infrastructure side, how we can get better utilization, all of those sorts of things. The kind of second area and second stakeholder is what I'm going to focus on today. It's the actual users or the administrators of the application side of the house. And I'm going to focus today on the benefits for them. And the third piece I'll talk about more in my keynote tomorrow morning, which is the what we call the business policy side, which are the rules that are kind of set at CIO level to determine how your cloud should run. And to really resolve a whole bunch of the different issues that are created in a cloud environment, and indeed in virtualization environments too. We'll focus on that tomorrow, but today we're going to focus on what we call the virtual enterprise, which is what the application team get, and it's all about providing them with empowerment to do what they need to do, but in a way that's completely risk-free to the IT infrastructure team. So I'm going to start out by explaining this vision slide here. which really gives our view of the world, not necessarily from our own product perspective, but from how we believe that virtualization 2.0, if you like, which is the move into the cloud, how it needs to work. And in this diagram here, you've got the gray ring around the outside, and that represents the physical infrastructure, the servers, the networking, the storage that makes up your infrastructure. And that could come from a whole variety of different sources. It could come from local data centers that you have in your own building. It could be remote data centers anywhere around the world that your organization owns. But it could equally come from a hosting provider and ultimately from an IaaS provider like an Amazon or a Microsoft Azure. They could all be contributing physical resources into this thing we call the resource cloud. It's kind of a notional thing, but it's there to separate the physical from the virtual world. And we believe that's really important, that separating those two completely, having them operate completely independently is very important. So the physical infrastructure contributes to that resource cloud, and the IT infrastructure team focus on delivering those resources at the required service levels and focusing on the physical side of the house. And then those resources are consumed by virtual enterprises, which are in the inner gray ring there. And those virtual enterprises, as you'll see in a minute, are divided up, and this is the area we're going to go into in a lot greater detail momentarily. Clearly, there's a point at which the virtual side and the physical side have to meet. So if you provision a virtual machine, it has to actually exist somewhere in the physical world. And in our system, in our vision, this is done completely automatically by the cloud management solution. And it's the cloud management solution that determines where in the physical world that virtual resource actually ends up. And it does so according to business policy. And again, we'll be focusing more on business policy tomorrow. But the enterprise itself, the virtual enterprise, substantially neither knows nor cares where in the physical world it ends up. As long as it meets their needs according to the business policy, they don't really care and they don't need to know where it ends up. And they certainly don't have any access to the physical machines. The system takes care of that mapping automatically for them. Also in this diagram in the center, we've shown image libraries, again an important part of the puzzle, so that you've got libraries that are perhaps local to an enterprise where it keeps its own images, virtual machine images. Perhaps they're, for example, snapshot images, stateful images of virtual machines that they've taken, backup copies, all of that kind of stuff, things they're working on that belong to their virtual enterprise. Then in the second layer up, you may have a shared library, which, for example, would be where the IT organization would place standard images. So here's our standard image of a Windows 2008 server. It's got the antivirus we require on it. It's got all of those other management tools that we require to integrate with the rest of our systems. But it's there, and you can take out of the library. So anytime you need a Windows 2008 server, you just pull it out of the library, and you'll see how easy that is to do momentarily. And then lastly, we have the public libraries at the top there. And public libraries are so that you can actually, if your administrator gives you consent to, you can actually download images from software vendors directly or from other sites around the web. Because we're finding increasingly that software vendors want to deliver their solutions through virtual machine images because it just makes the installation and creation process just so much faster for you. So that's our vision. Let's dig into the virtual enterprises for a moment. That's what we're going to focus on today and understand what they are and what functionality they give. So imagine this is our notional virtual enterprise, and we're going to make it for our trading operations, whatever that might be. And it will consist of, first of all, a set of users who are the administrators and users of that enterprise. Now, I don't mean from the actual users of the application. I mean the people who are actually running the applications, the IT application team. So the guys that run your mail servers or the guys that run your trading application in this case. So they are, first of all, as part of an integral part of this virtual enterprise. Secondly, you have multiple virtual data centers. And so they all form part of our trading operations, but notionally we've divided them here into two trading centers. One, and I'm obviously just showing two, there could be as many as you like. Two virtual data centers, one for our New York operations, one for our Tokyo trading operations. The next piece is that each of those virtual data centers has its own resources in terms of storage and networking and servers. And as you'll see in a moment, they're able to configure those any way they want to. Let's drill down a bit. But first of all, we need to consider that the virtual enterprise we have there has to have overall limits around what it can do. And they're set by the IT infrastructure team when they provision a virtual enterprise. It's just a logical unit, so this takes seconds. They assign what resources that enterprise is allowed to consume. And here we've got a bunch of different ones showing here, the amount of memory, the amount of virtual CPUs, the amount of hard disk locally in those virtual machine images, the amount of external storage they're allowed to consume. So, we've got NetApp devices or EMC devices or whatever, external storage that they're allowed to consume. We've got the amount of the repository, which is the library of virtual machine images, the amount that they're allowed to consume in there, the number of virtual LANs that they can create inside their enterprise. We'll dig down on that in a minute. The number of public IP addresses that they can consume. So all of those parameters can be set for a virtual enterprise. They're set by the infrastructure team, and then the enterprise is handed over, if you like, to the administrators of that enterprise. And once those administrators, the first administrator gets it, they are then in control of who else they're allowed to come in and control that virtual enterprise. So the IT infrastructure team provisions the enterprise, sets the overall resource limits, decides who is going to be the first administrator, and hands the enterprise over to them. And from that moment, and all of that takes seconds, from that moment, that administrator is in charge of the whole virtual enterprise, completely autonomous, can do whatever he wants within those resource limits, as we'll see. So let's just take our New York virtual data center a moment and just blow it up a bit. The way we actually organize it, remember I said it consisted of servers and storage and networking. The way we actually bundle it together in our product is to have storage and a series of what we call virtual appliances. And a virtual appliance, if I blow it up there, is just a collection of one or more servers. Now, if you were just thinking about wanting to deploy a single virtual machine image for a simple application, then your virtual appliance may just consist of one VM. That's it. But you can bundle them together, and that's important, as you'll see as we go through. And that virtual appliance has a series of connections. And those connections could be to storage, as we've got there. They could be connections to other virtual appliances. They could be external connections to the outside world. But those are all considered to be part of the whole virtual appliance, that connectivity. So let's see what that means in practice. If we look here, this is the screen where we're managing our virtual data center. So here at the top, we're on the virtual data center tab. And notice here, we don't have any concept of the physical infrastructure. If we were a manager of that physical infrastructure, we'd have another tab on here to manage that, but we're not. We're the manager of a virtual enterprise. And in our virtual enterprise, we've created two virtual data centers, one for New York and one for Tokyo there. What I'm going to do is show you what the process would be to actually go and deploy a virtual appliance. We'll start with a very simple one. We simply give it a name. We tell it this is the name of an appliance we're creating. We're going to call it our trading database. We say in which virtual data center we want it to be. Pretty easy. And there it is created. Now, nothing in it at the moment. It's not actually doing anything. As you can see, the little red light's on there, which means it's not running. And now we decide exactly what we want to be in that virtual appliance. And here on the left-hand side, we have this is our library of VM images, and there are two tabs on there. One for the ones that are in the library that are master images, if you like, and the other are stateful images. So these might be machines that we've saved, virtual machine images that we've saved. But we're looking at the master images, if you like. You can see they've all got the little M in the corner. And here, this is our library. We've got a bunch of tabs of different things that have been provided to us there. If we have permission to do so, we can upload our own virtual machine images into the library. But here is an Oracle. We're looking in the database tab. Here we've got a MySQL or an Oracle database available to us. We simply grab hold of that, drag it and drop it over here. hit the save button, hit the power button, and that's it. It's running. Now, what actually happens when we do that process of hitting the power button after we've decided what's in our virtual appliance is a three-stage process. The first stage is that our business policy is applied underneath the covers by the system to determine where that virtual machine is going to run in the physical world. We don't see any of the results of that. We don't need to. We know that it's happening according to our business policy, and that might be determining obvious things, first of all, like out in the physical world, which machines are actually running the right hypervisor and actually have the right amount of, enough capacity to take this load that we're going to give them. So that would be an incredibly simple policy. But then we may have many more complex ones. The next issue is, we could place it in all of these places, but which is the best place to put it? Remember when we saw the video at the start, we had that issue about where do you actually decide to put it? Where is the most efficient place to put this? And if you use business policy to determine that, it's much, much more efficient than having a human decide, which is how it all happens today. More of that tomorrow. And then other decisions around security. Where are we happy that this workload should run in our data centers, or are we happy for it to go run at Amazon? So depending on who we are, the rules for our virtual enterprise, our trading operations, may say we need to have that. Anything that happens in our trading operation has to run in a data center we own. That could be one of the business rules. And therefore, obviously, any hardware that's outside of that scope will be discounted. We might have a compliance rule. For example, in Europe, there are rules around HR data. You're actually not allowed to transport people's HR data across a country border in the EU. So if this was my HR enterprise, then I might have a rule which says, okay, you can use any data center within my country, but you can't go outside for the HR France database enterprise, for example. So just examples of policy rules. Now, all that takes a fraction of a second to actually determine, whereas it would take a human a long time. You saw the guy with his clipboard trying to work out where to put everything. Using business policy, it takes a fraction of that time. And the great thing about business policy is you don't have to worry about it. It happens every time you start a virtual machine. Every time. You don't have to think about it. It does it by itself. And every time it's going to get the right place. That's impossible in a practical sense for a human to do. If you've got 1,000 physical machines out there, there's no way you're going to be able to determine where the best place to put it is. You're going to do that, which is what happens today, and that's why we don't get the utilization rates that we really desire. More of that tomorrow. So we've determined where to put it, and the next thing is to take this virtual machine image here and actually copy it out to the physical server that we're going to run it on, assuming it's not there already. If it's already there, it won't do it. And then we actually boot the thing up. And all of that takes far longer to say than it does to do. If I'd actually shown you this in reality, that Oracle server would have been running inside 20 seconds. So just showing you the power of what the administrators, the users of that virtual enterprise get. No more having to wait for IT to go and provision a machine. Drag it, drop it, hit the save button, hit the power button. 4 clicks. Okay? And there is our trading database, green light on, it's running. Here's another example of the virtual appliance. We made this one a little bit more complex. And this really shows you what the benefit of that appliance is. Here we've got 5 servers that have been grouped together. Instead of just the one that we had before, we put 5 servers in our appliance. And you're losing the top left of the screen there. It actually says web farm at the top. This is a definition of a web farm. And it consists of these components: a pen load balancer at the front, 3 Apache web servers behind it, and then a MySQL database behind that. And you can configure all of the networking and storage that's to be associated with this appliance. In the first example, we just went right ahead and just said, OK, there's the VM image, run it. In this case, we can do much more complicated things than that. And if we take a look inside, you'll see here is the networking, for example, and we've defined, this is the pen load balancer at the front I've opened up here. And we've defined 2 virtual network interfaces to be on that. One has a public IP address that we've taken. We were allowed a certain number of public IP addresses. We've taken one of those, and that's now facing to the outside world. And we've defined a second virtual LAN here to be the internal LAN for our operations. So we've got 2 interfaces in there, one to the outside world, one to all the components on the back end. And you can see now how flexible you can make your configuration. It is just like you've got your own physical data center there. There are no limits into how you can configure it. It's virtually the same as being able to rewire the whole thing from scratch. So any kind of configuration you want is available. And do exactly the same for the storage. This is external storage, not the storage inside the virtual machine image. This is external storage. So I've actually taken my available volumes that I've got available, and I've actually said, okay, we need in that image, in that appliance, a certain amount of storage. That's what we need. Bundle that up with the appliance too. And the great thing about having an appliance like that is when you can save it as part of your library. You can save that whole bundle into your library, and next time you need a web farm, instead of having to have to go out and configure all of those components, you just drag and drop the web farm over, hit the power button, and all of those, not just that virtual machine and its network interfacing, but all the connections to the other ones and all the storage will all be worked out for you automatically. You don't have to do any of it. And up will deploy that web farm in a single operation, 4 clicks, entire web farm. Okay, so it's a really big time-saving device. Let's talk a bit more about the virtual networking because it's particularly important. This is where the screen on which we configure a virtual network. And in each virtual enterprise, you can configure in each virtual data center, you can configure as many as you want. And here we've got one that's given to us by default. You can tell the system not to give you a default one and make you define it every time. But by default, it'll always give every virtual data center a 192.168 LAN there. But if we go on to look at the second one, if we create another one, so I just say create a virtual LAN, I tell it what I want to call it, I tell it what numbering scheme and netmask I want it to use, I tell it what I want the gateway and DNS addresses to be. So, just like configuring your own system as if you had hardware on-premise, all of these things are available to you. And then if we go and that will then appear as if I go back one, that will appear as your second web farm internal there. And those will have the 10.0 addresses that we talked about before. Okay? This is the public side of it. Moving over to the public tab. And here are the set of public IP addresses that have been allocated to us. It told us we were allowed to have 10 or whatever it was. There they are. And you can see also here which ones have already been assigned to other processes. So you can see exactly what you've got left, what's available. You pick one of those, and that's the one that we said would go on the front end of our load balancer at the front of our web farm. So let's just explore that VLAN tagging a bit more, because some of you, I'm sure, will have spotted a flaw in that. And the flaw is what happens if 2 different virtual enterprises or 2 different virtual data centers define that they want to use the same set of numbers, same set of IP addresses. Well, in fact, it doesn't matter at all, because all of this is on a virtual LAN basis. And behind that, we're automatically managing those against a standard commodity 802.1q switch. Okay, so this is just a vaguely intelligent switch. We're not talking about megabucks. These are commodity items, $500 type thing. And what we're actually doing is taking those named networks that we had and converting those networks into VLAN tags behind the scenes. So when we actually deploy a virtual machine that's supposed to be on VLAN A, we will say, aha, we know that VLAN A, we're using VLAN tag 1 in that data center to deal with that particular named network, and we'll make sure that anybody else gets to the same thing. But if you define exactly the same thing with the same name in a different virtual data center, we will use a different VLAN tag. So even if you use exactly the same numbering system here and here, and even if you used exactly the same names for your virtual networks, they still will actually end up as different virtual networks on the back end. And that's incredibly powerful. So just to go through those VLAN capabilities in more detail, or in summary rather, requires only commodity switches to do that. You don't have to buy a particular brand, you don't have to buy a particular model or anything like that. Commodity VLAN switches, as long as they're managed switches, 9 out of 10 will support that tagging. You can, depending on which type of switch you have, they either support 1,024 or 4,096 VLANs per switch. And there is no limit to the number of switches that we can manage. Even in a single data center, we can manage as many as you want. And the typical way of doing it is to put one switch per rack. So top of rack switch, all of the physical servers underneath it. And that gives you typically 4,000 odd VLANs that your users of those switches can create. Okay. We have an unlimited number of virtual network interface cards per virtual machine. You saw 2 in the example there, but there is in fact no limit. It's only limited by what your hypervisor is able to cope with. So, 8 is almost all hypervisors would cope with at least 8. So no matter how complex you want to make that networking inside, you can do so. We've got the name networks, as you can see, completely isolating you from that sort of nasty tagging stuff. We deal with that on the back end. And just worth remembering that I've drawn this very simply here. Of course, in reality, it doesn't end up looking like that. It ends up looking like a huge pile of spaghetti. Because, of course, B didn't come immediately after A and C didn't come immediately. It'll be that one, then one of these, then one of those, depending on which order they are created and destroyed. So that's a fair management task to deal with those. But the system does that automatically. Completely unrestricted network addressing. You can create whatever numbering system you want, as you saw there. And it doesn't matter if 2 different data centers do the same thing. We've talked about the public IP allocation. And in fact, we can also support creating multiple public VLANs. So you can have a VLAN path to the outside world as well. So if you want to have, if you've actually got, multiple different network providers or whatever, you can have individual VLANs to go out to those different public ISPs providing you those addresses. It's also important to note that as well as you having a limit set by the IT infrastructure guys on what you as a virtual enterprise can consume, you can also set limits yourself on what each virtual data center can consume. So I know I've got a certain amount of resource that I can use in total for my virtual enterprise. I don't want a particular virtual data center eating all of that up. So I can set my own limits for there. And here you see again the limits. The one that's missing, by the way, if it looks smaller than the others, is the repository, because the repository is shared across them all. But I can actually allocate my limits across individual data centers. Now, in this case, they're all 0, which means don't limit the data center. So that data center could use up right up to the maximum that I've got allocated to my enterprise. But if I don't want to do that, I can actually limit down what each enterprise can use, each data center can use. So let's talk about a few use cases here and see where this really plays out. The first is if we talk about an enterprise. And enterprises today, all of the provisioning, physical and virtual, is done by the IT infrastructure team. That's a gigantic bottleneck. It means that when you want to, as an application guy, when you want to get a new machine provisioned, you have to go to the IT infrastructure team and say, please can I have another machine? And it takes however long it takes, depending on who the company is. It can be days to weeks typically. You can now do that in seconds because we've devolved that process out to individual application teams. So now we've got something that scales for a start. It doesn't have to all go back to those poor guys in the IT infrastructure team. You not only take charge of your own destiny, but that load is spread. The other important point about devolving it like this, you get control of your own destiny. Lost my thread slightly. I'll come to the next one. Let's look at the provisioning. If we talk about this in a hosting provider sense, slightly different in a hosting provider sense because you don't now have users of application users. You have customers. So the hosting provider now has a different thing to sell. Today, hosting providers sell you, they sell you rack space, or they tell you dedicated servers, or they sell you a web server, or sometimes an application server that's all dedicated. Now they can sell you a virtual enterprise. And the 2 benefits of that are, first of all, to the customer, he gets a virtual enterprise that he can configure anywhere he wants, just like it was hardware on his own premises. He just doesn't have to maintain it. You've seen that. Okay? But equally, the hosting provider doesn't have to go and provision those virtual machines. And in the hosting provider world where your margins are incredibly tight, you don't want humans getting involved doing that stuff. Now they don't have to. It gets done by the system. let's just look at two different models in which the hosting providers could actually sell this. The first is how you might imagine. The customer, the end user, if you like, XYZ Corp, has the Abiquo solution on its premises, and it has its own hardware, and it reaches out to the hosting provider to provide elasticity. That's the kind of the traditional vision that we have of it. You use your own resources to create a private cloud, as it were, and then you get a hybrid cloud by buying in resource from a hosting provider. The key difference here, and it's very well worth remembering, is one of the big issues with an infrastructure like an Amazon is that you don't have any visibility into the infrastructure. All you see is your virtual machine. You have no idea where it is in the real world. Nobody has visibility of where that stuff is apart from Amazon. So that gives people the heebie-jeebies. They don't know where their stuff is. That makes people nervous. Here you do know, because you know exactly in which hosting provider it is and exactly which hardware has been allocated to you inside that hosting provider, so you know exactly where everything is and you know it's following your business policy rules. So that's the traditional model. You're doing elasticity out to a hosting provider. But there's another interesting model that's developed amongst our customers, which is where the hosting provider says, I will host the Abiquo application for you, and I will take my resources that I have dedicated for you in my data center, and I will add your private cloud into that. So it's the reverse of what we talked about before, meaning that the hosting provider manages all this stuff for you, and you just add your physical resources into what he's using there. Now, of course, using our software, he reserves those machines so they're only available for your use. So you don't want other people's stuff running on here, unless you choose to, unless you choose to sell your resources to other people, which you could do. But that's not what we're envisaging, at least to begin with. So you control, using that business policy, you say, my data centers are only to be used for my virtual enterprises. Simple. Okay? Just another twist on the model. So I'll just sum up by saying the virtual enterprise that I've shown you provides total flexibility. This is the key benefit to either the hosting provider's customer or to the application team. It's clearly empowering your users. Not only do they have the flexibility, but they now can provision whatever they want, whenever they want, as long as they stay within those limits that you've set them. So they can't exceed them, they can't play with the hardware, they can't interfere with anybody else's stuff. It's all isolated. But they're completely empowered to do what they need to do. Clearly, the provisioning effort has disappeared, so agility returns. You don't have to wait for the IT team. So if you want to do a what-if scenario or a short-term project or those sorts of things, that's now a possibility, whereas it was unrealistic before. And the whole system provides completely unlimited scalability. Thank you very much.